Welcome to Swell Academy. Today we're talking about a tough one here, graphing sine functions. A lot of different pieces, but all of these pieces really tie into each other. So basically what I want to do is just take you through and look at a few things, a few ways, and see if that can't give you an idea of how to graph a sine function or how to take a graph of a sine function, come up with an equation. First thing we want to look at is this idea of taking a unit circle, which we have here, and if we're going to sit here and take basically our, in this case, like a pi over 4, take a radian and graph its sine function, which in this case is our y coordinate. So if we're going to look at the unit circle and look at, okay, if I have a or if I take the sine of pi over 2, if I take the sine of that, I get a result of 1 here, my y coordinate. And if I'm to graph that, you see the relationship here. Here's your pi over 2, and here's your 1 or your y coordinate of cosine and sine. There's your y coordinate here. So if we're graphing the y coordinate as we go around our sine function, for instance, even if you're looking at pi here, come in this direction, and we have our pi, you can see our y coordinate here is 0. So it's basically as if we're going along this, get a brighter color here, we're going along this unit circle, and as we go around, and we're creating this radian, this is kind of, each of these points is this moving development of our graph here. And you can see, how some of these values here, let's say from here to here, where our y is negative, you can see this is essentially this part of this graph here. All right, so just a couple different ways of looking at it. And again, if we're looking at, grab an orange here, the positive values of our y, if we're going around moving, positive y, positive y, positive y, positive, decreasing, that's this part of the positive y, positive y, positive y, positive y. And this is where we switch to negative here, and that's where we see the switch to negative here. So basically this graph of sine is a graph of as we go around our circle of a unit circle. Now a couple things is, one, you want to look at the period and frequency of a sine function or graph. So this idea of period and frequency is this idea of your distance between two maxima. Now let's just look at our regular sine function here. Let's say here we have two maxima. We're looking at our regular, this red graph is our graph of just a regular parent function of graph of sine here. And if we look at the distance between these two maxima, we have a period of 2 pi. So this whole idea of, in a regular sine function, if we don't change anything, the period tends to be 2 pi. And we look at that again, going back to our unit circle. If we make our way around the unit circle from here all the way back around, we've gone a distance of 2 pi, right? If this is a unit circle and it's got the name of a unit circle because it's radius of 1, and we do 2 pi r, radius of 1 here, we get a circumference of 2 pi. So as we go around our circle, a full period we would say is 2 pi. So the distance from here to here we're looking at, and the same thing, you could look at even the distance of an intersection. If you're looking from, okay, well, we start at 0, so yeah, here's 0, and 0 to 2 pi, that is a distance. That's a full let's say I like to use a word, that's a full cycle of the graph, I like to say. So, you know, here, 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 and then back to where we started, from where we started. This is a full, call it a cycle, a full period. Now, if you were to take this graph, and if we're at 2 pi here, let's make a little line in red for 2 pi, and I were to increase that frequency maybe by 2, and let's say in between my maxima or my maximum points, let's just look at something that would be like this. Maybe I have a sine function that looks like this here. This is what we're looking at. I probably should have used a different color there. Let me bring this teal out here, or lighter blue. So we're looking at something like this. Now the distance between here and here is pi. So my period in this case is pi. Now the frequency of it, you're thinking in terms of how many times does it happen within a full like a full 2 pi cycle. If you see, it happens once, twice. So actually the frequency of this is almost like your reciprocal. It's 1 over pi, meaning that each of this 2 pi is being broken up into two like 1 pi's of a cycle. So if a full cycle is 2 pi, and then I'm saying the frequency is 1 over pi, you get 2 pi over pi, then basically I'm saying my frequency is 2. That within a span of 2 pi, I have 2 cycles there. So my frequency is basically every 1 over pi, okay? Or no, we're looking at more so my period is every pi, I have a full cycle, and my frequency, I'm basically saying I'm taking this 2 pi and I'm dividing it up by pi. So my frequency is 2. That's a way to look at period and frequency. And then you can have something that has a far greater distance, maybe from here to here, which has a period of 12 pi over 3 or 4 pi. And you're saying my period of my function is in this one is more so 4 pi. So what we're saying is the distance from a maxima to maxima is about 4 pi, meaning my frequency is 1 over 4 pi, meaning that we're going, so, if we take that 2 pi and we divide it by 4 pi, that I'm only going to get a half of a cycle. And again, if we're thinking a cycle as being a full, back to where we started, I'm only getting a half cycle within that 2 pi. And it makes sense because if you look, a full cycle on this graph is, if we're at like 4.7 here and we go here, 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 and we want to get back to 4.7 here, let's say that this orange version is our full cycle there. We see we really only completed about a half of that up until 2 pi when we got to 2 pi here. Now when you're solving for your b, for instance, in your function, which is this is, b represents your period / frequency of your graph. What is the multiple? How many times is it happening? So in this case of this graph here, let's call this graph A, whatever this is, our actual frequency is about 1/2. So we're dividing, we're saying we're only going to have a full cycle about half the time during that 2 pi cycle, where this one here, call this graph B, we had we actually had a full cycle of 2. So in this case, uh, RB for this line would be 1/2, and RB for the green line would be 2. And what we're saying is that our frequency is half the normal or 2 times the normal. This is where we come up with our B. This is period of frequency. This is the one that kind of can be a little confusing, finding B, what is a period, what is a frequency. Now, a formula you could use to find your B, easiest way, is just say, well, B is equal to 2 pi over B. And if you're thinking about it just like we did, if we know our normal cycle, our normal frequency is 2 pi, so we have 1 maxima to maxima over 2 pi, then my B is basically however many times I divided or multiplied that. So for example, if I use my A graph, which has a function period of 4 pi, then what is my B? Well, I could say, well, 2 pi over B needs to be equal to 4 pi. What I usually do, and usually what I do is to solve for B, I kind of give it a quick flip, which you could do in math. I say absolute value B over 2 pi is equal to 1 over 4 pi. And if I multiply both sides by 2 pi, I get 2 pi over 4 pi, which is, pi's cancel out, which is 1/2. And that's what I got here. And basically, this is what you're saying. In a full cycle, how many of 2 pi, how many cycles will my graph have? So this is how we're solving for B here. Another thing you want to look at, amplitude. So here we're looking at our amplitude. Amplitude's a little easier. It's basically from your midline. Now, let's not go to midline. It's basically you're looking at top to bottom. So in this case, 2. And this is your A we're solving for. So this has top to bottom of 2, and you're dividing by 2, and we're saying we have an amplitude at 1. But the understanding is that if we have a midline, a line dissecting straight down the middle of the top and bottom, if you see, in reality, we are going up 1 and we're going down 1. So it's basically our amplitude is from our midline, how high are we going and how low we're going. That's where your amplitude comes from. So that's why they tell you to take basically a total distance here of 2, divide that by 2, and then you get this idea that, okay, we have an amplitude of 1, and that is our A here. Now, you could do the same for this graph here and say, well, from my midline to here, I have an amplitude of 2, or you could have said, well, I have a total distance from, now let's do a total distance y to y over 2. So I love this because any y's you give me, the top of my function is 5 minus the bottom of my function here, which is 1. That's 4 divided by 2. That's 2. I have an amplitude of 2. This is how we solve for our A here. And this is the number you see here. Just like we saw the number of our B here, this is how we found our period. This is where our 2 of sine to the 1/2, this is where our B value is coming in. This is where our amplitude is. Now the other two numbers we're looking at is we're going to look at this value here, which we call D. This is your vertical shift. So, and be careful, because sometimes a vertical shift just looks like, oh, that's just my, for instance, this case, this parent function, our vertical shift is 0, so it crosses the 0 here. It's not your y-intercept. It's where your midline, your D essentially is where your midline crosses the y-intercept. Where is that? So if you see here, our midline of this graph here is actually +3. So it's up 3. If you see the center of our graph, if we were to split our graph horizontally down the middle, so your D in this case is more of your vertical shift, based on a, coming down here, based on a horizontal split. That's basically what we're looking at here. And so really all you need to do to find this value D when graphing is just find your midline and see where it crosses the y-axis. Now a little bit different is your C in this case, which is more your horizontal shift, more of your horizontal shift. Where if you look here, we don't have any horizontal shift, so we call it 0, but we have here a shift of 1. And the best way to find that is, well, what you could do is you could say, take your function. We know our a to be 2. We know our sine to be 1/2 x. We don't know our c. Let's just say in this case we didn't, but we knew that our horizontal shift was 3. What you could do is take any point on this graph, any point, let it be, pi over 3, any coordinate on this graph, and substitute it in for your y and your x. You could take any point. Let's say maybe this was 0 and 4.75. You would be able to plug that in essentially and come up with a horizontal shift. What we're seeing here basically is you have, if I were to make a line here, we have our x equals 1 here. That's kind of where your horizontal shift comes into play. Usually you look for any coordinates that have a 0 in the x or y axis, and then you'll plug that in and you'll solve for c. Let's just say in any case you ended up with, let's say 1 is equal to sine c. Let's just say the best way to solve for what c is, just say c is equal to sine inverse operation of that 1. So again, a lot of pieces going into the development of this graph. The best thing to do, of course, is to practice, because the more you fail, the more you succeed. But this is just basically a look into A being your amplitude, B being your period and frequency, C being your horizontal shift, and D being your vertical, and how that plays to the unit circle, and so on and so forth. So just a crash course, basically a look into this and giving you an use of Desmos and all that stuff will be a big help as well. Again, hope this helps. This was a long one, but a lot of information to give. Just take it piece by piece.